This issue explores absolute time and absolute space. The concept of absolute time and absolute space comes from the great scientist Isaac Newton. What is absolute time? In his book, Mathematical Principles of Natural Philosophy, the time is described as follows. Absolutely, real and mathematical time itself is passing, and by virtue of its nature in uniformity, it passes without anything outside world. In Newton's view, time is the same for anyone, never linger and never stagnate. An obvious fact is, time has nothing to do with humans or any other object. No matter how we do it, time is passing at the same pace, and nothing has changed. Lamenting the eternal passage of time and the shortness of life. From this feeling of irretrievable and unstoppable time, it's called absolute time. If you go from one country to another, you'll need to adjust your clocks to suit the local time. So suppose at this moment all the clocks in the world are gone. What will the time look like? The answer is that time lives on and will continue to walk. Expand the scope a bit. Suppose all the atoms or particles disappeared along with the clock. What about time? Or a little more serious, suppose the Earth, the Sun, the Milky Way, and even the entire universe were gone. What will the time look like? Some people might think that since the whole universe is gone, nothing exists, and the time certainly doesn't exist anymore. But in Newton's notion of absolute time, even if the entire universe is gone, time still exists independently. It has nothing to do with anyone and everything and will always exist. So what is absolute space? Also in Newton's book The Mathematical Principles of Natural Philosophy, Newton described absolute space this way. Absolute space by its very nature, it is independent of anything outside and is always the same and immovable. It's the same as absolute time. Absolute space also exists independently of anything. It's like a stage, even if no actors are on stage. The stage is still independent and forever. In order to prove the existence of absolute space, Newton also conceived an ideal experiment specifically. It is known as the bucket experiment. In the bucket experiment, Newton postulated that there was a bucket filled with water that remained stationary. After that, tie the handle of the bucket with a rope. Hang the bucket from the branch of a tree so that the bucket starts to rotate. In the beginning, the water in the bucket remained still. But it wasn't long before it started turning along with the bucket. The surface of the water will gradually break away from its center alongside. The walls of the barrel rise to form a concave. Newton believed that the formation of a concave shape on the surface of the water is the tendency of the water to detach from the rotating shaft. This tendency does not depend on any movement of the water relative to the surrounding objects. That is to say, this is the bucket relative to absolute space rotation. The idea of absolute spacetime embodies one of Newton's ideas. The moving is always moving, and the static is always quiet. And it is this absoluteness based on time and space. Newton constructed the laws of motion. In expounding Newton's first law of motion, Newton based it on absolute spacetime, on a frame of reference that depends on anything in the outside world and exists on its own. In absolute spacetime, objects have the property of maintaining their original state of motion, which is inertia. However, although the idea of absolute time and space, it is the basis of Newton's theoretical system. However, in the 200 years since it was proposed, it has been questioned, and caused a lot of trouble to Newton himself.